Hello everyone. In this part of the video, we'll mainly cover the technical aspect of JanSevak, a detailed workflow on the web app. Designed with a singular mission, it's dedicated to empowering patients in the quest for seamless medical healthcare. We have utilized Flask as a Python framework along with Jinja template for the front end of the website. For the backend, we have used MongoDB for its scalable nature. We have also employed Redis for handling user states and managing cache, especially crucial for various generated prescriptions and web artisan methods within the system. So this is the landing page of JanSevak. Let's first log in as a patient to visualize the various functionality it offers. So let me log in with a patient credential. Here, once the user is logged in, he or she can visualize the various services and features offered by JanSevak, along with that the list of available doctors in this time frame, and also many other things which I'll come to back later. Firstly, we have the JanSevak chatbot, which is knowledge trained using Dialogflow. We have utilized a custom BERT model, which is hosted in our GCP console, to which caters to the user specific needs and behaves as a healthcare physician only. Due to the LLM model being heavy, we have used Express and then hosted it live on GCP so that it can offer a very low latency and can give a fast user response. Let me first give in a prompt to see how it works. Let me say I am having a headache and also slight fever. This gets passed to our LLM model, and quick response is generated through our LLM model where it suggests some home remedies along with some yes medications. Uh, we can also show you how our API actually works. Here's an API currently running on our Express server. Let me say I am having a bleeding nose, and yeah, what to do? As soon as I send a post message, this gets passed to our LLM model, and here you can see the response that here are some suggestions given by JanSevak, also some homemade remedies and clarifications if needed. So this response basically gets formatted in our Dialogflow console. Along with that, the user also have an option to book a one-is-to-one video conferencing with a doctor in real time just by typing the word confirm, and JanSevak will automatically do what needs to be done. By typing confirm here and on the doctor's approval, an in-app room ID will be generated for them, which for them to get diagnosed. Well, there's another way of doing that. Here's how. The patient has an option to book an appointment here. Let me book an appointment as Abhishek. Let's say 21. Here the user can select a time slot based on the doctor. Let me select a dermatologist, and when I book, this gets passed to our MongoDB database. Along with that, SMPT server is getting generated where the doctor profile gets a new here. Now we can see that the appointment is in a pending status. Let me first log in as a doctor and then approve the patient. Let me log in with the dermatologist credentials. So this is the doctor dashboard, and here you can see there's an appointment request as approved. And let me first approve it. Once the doctor has approved it, corresponding mail will be sent to the patient as appointment approved, and the doctor has the option to even prescribe medicines here. So once he goes to the patient profile, he can prescribe medicine here. Prescribe. Here are a list of available medicine. This can be customized as per needs. So let's see this and submit prescription. This gets saved as a user state in our Redis database, and a corresponding prescription gets generated here. Let me save it as a PDF. Here's a generated prescription which is even sent to the patient as well as to the doctor database. So coming back as a patient, as you can see, we are now in our hosted application. Now there is a feature where a patient can have a one-to-one video conferencing with a doctor in real time. Let me first initiate this process. Yeah, as a doctor and with my name, a personal link will get generated. This basically comes in the user email ID and as well as to the doctor's email ID. So here the user can join in a room, and as well as a doctor can join in the specific room ID. This is all maintained using Redis and WebRTC. So Rohit, being a dermatologist, can have a yeah. Let me move in. Have a one-to-one video conferencing here. Also, if the patient is an old patient, his past prescriptions can be viewed here by the doctor so that the doctor can focus more on patient health than on his reports. The user has also an option to chat here with the doctor in real time. So this is our one-to-one video conferencing feature. Some of the other features JanSevak incorporates are disease prediction using various deep learning algorithms. This reduces the workload of doctors as well as serves as an early diagnostic tools for patients. Let's see it in action now. Here are some prediction tools offered by JanSevak. If I were to detect any lung infection or malignant tumor, I can just put in my X-ray scan and it will pass through our model hosted live and given the corresponding prediction. Let me put in this. It tells that influenza not detected. Similarly, let me put in another image for testing. In this image, there's an chances of influenza. Similarly, this works for brain and even for cataract disease prediction, wherein I have the option to put in eye images or retina scans, no defects detected, cataract detected. We can even predict disease using the KNN architecture and using the a priori classification algorithm. Here's a quick run on how it works. Let me select a few symptoms. It predicts drug reaction due to the fact I chose randomized symptoms. This data even gets saved in the user's profile, enabling JanSevak to constantly monitor the patient health time to time. Next up, promoting mental well-being, we have also incorporated a mental health chatbot, also trained using the a priori algorithm to understand the user's mental health. Also note that right this chatbot right here also serves as a mental health care specialist to serve the patient's need. Let me put in a couple of user accounts. These are a list of questions on which our KNN architecture is trained on, and a corresponding generated message gets here, and also this gets saved in the user's profile as well so that the doctor can constantly monitor the patient's health time to time. Below here are some blogs to promote healthcare which can be put on by healthcare specialists and doctors on their specialization to encourage good habits. Here's one like promoting fitness and yoga. Herein, verified healthcare specialists can put in blogs to promote good habits. Next up, in this About Us section, we the two developers from KIIT are always open to contributions. We are dedicated to promoting healthcare and aspire to make this project a success, aiming to scale it to a global level as much as possible. Together, let's make a positive impact in the world through the commitment to social healthcare and technology. Thank you.